Hello, heating and air conditioning students. Hope everyone's doing well at home, and those of you that have to work, stay safe. This week's lesson is going to be about doing an air conditioning performance test. The vehicle we have has a thermostatic expansion valve system. Now that's different than the cycling clutch orifice tube system that we looked at on the Taurus, 2 or 3 weeks ago, last time we were in lab. The other difference, this is an electronic automatic temperature control system. So that doesn't really affect the refrigeration system so much, but it does change how we have to do the testing, what we have to do with the controls inside. I'll show you both systems, show you the difference between them, and then we'll go ahead with the test. At the end, I'll come back and try to do a little bit of a summary. What we're looking at here is a manual AC heat system. How do I know it's manual? Well, the biggest clue is the temperature selector here. It just has cold and hot. No temperature settings, anything else. The other thing, there is no auto mode anywhere. The mode selector switch over here, we have off, we have floor, mix, which is a combination of floor and defrost, and then on the cooling side we have vent, just lets fresh air in from the outside, no refrigeration going on. Normal AC takes outside air, cools it and sends it in, and max, which takes inside air from inside the car, sends it back through the refrigeration system and sends it back into the car even cooler. The fan speed is all manually controlled. We have low, medium high, and high. So this is manual AC heat, no automatic control of it whatsoever. Today we're going to do an air conditioning performance test on this 2015 GMC Sierra. Customer is complaining that the air conditioning doesn't seem to be blowing very cold. So how do we decide whether the customer's complaint is valid? We do an air conditioning performance test. This is an electronic automatic temperature control system. Things you can use to identify it as an automatic electronic temperature control system. First thing is, notice it says auto here. You can change to a different mode, such as defrost, or you can split between defrost and floor. But if you put it on auto, it will automatically determine whether the air needs to come out the panel, out the floor, out the defrost. Right here is a recirc, or a max AC button. That'll give you the maximum cooling. But on auto, if it's warm enough in the car and warm enough outside, it will automatically do that. The other thing that identifies it as automatic is you actually have temperature settings here rather than just hot and cold. So here, for example, I can set it to 70 and it will automatically try to maintain 70 in the car. This is a dual zone climate control system, which means I can have separate settings for the driver and passenger. Right now, the sync light is on, meaning that whatever happens on the driver's one will also happen on the passenger one. If I turn that off, the passenger can choose, here's 75 on the passenger side, only 70 on the driver's side. And so they're separate controls. I can turn the entire system off with this button here. And then to put it back on, just push auto and it'll come on. And try to make the car the temperature that you have selected here. And send the air out the appropriate register. So to do an AC performance test, one thing we're going to have to do is turn both sides, or I'll hit sync so I can just turn this side. It goes down to 65, then after that, 64, I'm sorry, it goes down to 60. After that, the very next setting, it just says low. that's going to be maximum cooling. And if you're doing a performance test, you have to be on maximum cooling to make sure that you're actually testing the performance of the air conditioning system. Before we can do this performance test, one of the first things we have to do is look up how the test is done and what the specifications are for it. So on ALLDATA, I've brought up the vehicle, a 2015 GMC 1500 four-wheel drive with the 5.3 liter engine. Under heating and air conditioning, over here, testing and inspection, the initial inspection and diagnostic overview gives us the choice of AC performance test. So the performance test could be different on RPO L83 or LV3. So what does that mean? Let me go back to the vehicle level and look at our RPO code list down to L's. And see, the L83 is the 8-cylinder 5.3 liter, where the LV3 is a 6-cylinder. So we want to go with the procedure for RPO L83. That's our regular production option L83. So we'll go back to the performance test choices, click on that, and it's telling us this is going to measure the operating efficiency of the AC system with the current ambient air temperature, the current relative humidity, and we're going to check the high and low side pressures of the system and the temperature of the air being discharged into the passenger compartment. What we're going to do before actually running the performance test is make sure that it's safe to run the air conditioning system at all. If it's completely empty, that could mean there's no oil in it and it's not safe to run the compressor. So they want us to hook up our air conditioning service station, check the pressures static, which means engine off, air conditioning system not functioning, and make sure that depending on the temperature in the shop, so in the shop it's probably not much more than 60, we want to make sure we have at least 50 psi before we go ahead with this test. So that's what we'll do first. Before we can hook up our service equipment, we need to identify our service ports. We've got a high and a low side service port. The ports are here and here. Now when I take the protective cap off, you'll notice the low side port is smaller than the high side port. That's probably the easiest way to remember it. Big equals high side, small equals low side. You don't want to lose these caps, they keep dirt out of the valves. I've now connected the high and low side hoses to the service ports. The low side hose and valve, you'll notice, is blue. High side is red. Before we can get any readings off of these, we need to open the valves. So by turning the knob clockwise, that will push on the Schrader valve inside the service port and allow the pressure inside the system to reach the gauge on our service equipment. We can see now, looking at the gauge, that this system is severely undercharged. It's only showing about 5 pounds of pressure in the system. So that means it either has a major leak or somebody opened the system and didn't recharge it. So we can't go ahead with the performance test. We'll probably first have to do a charge on it and then look for leaks. We've followed the instructions in step 1 here. Park the vehicle or inside or in the shade. Open the windows in order to ventilate the interior. Allow the system to equalize for 2 minutes. Turn off the ignition, install the air conditioning service center. Check the ambient air temperature and humidity. Record the low and high side static pressure readings. So there's no question, there is no temperature on this list where the pressure should be 5 psi. We are nowhere near the 50 minimum here. So the question is, are both the low and high side pressures within the specified value? And they are absolutely not. So we are going to go to leak testing. As you can see here, leak testing begins with a visual inspection. GM vehicles are equipped from the factory with fluorescent dye in the refrigerant. So it may be visible to the naked eye. We're going to look for signs of lubricant leakage. So there's oil circulating in the system along with the refrigerant. If there's a major refrigerant leak, oil will also leak out of those fittings or components. So we're going to just visually inspect for any kind of oil or damage that might indicate that we have a leak. If we don't see anything that way, we're going to use an ultraviolet light to look for that fluorescent dye. And the most obvious places to look are underneath fittings. The refrigerant is heavier than air, so it tends to go downward when it leaks out. So we're going to look under all components, under all fittings for signs of leak, either just through visual or through UV light. Starting here at the thermostatic expansion valve at the firewall, we can follow the lines. Here you see we have the low side fitting. Here the high side fitting. Looking for any signs of oil or anything else that would indicate leakage. The rubber line here, that's the low side. High side is down here lower. Both go back towards the compressor. The low side goes into the compressor. The high side one is coming out of the condenser. We can try to follow that. The other thing we can do is try to get a look at the condenser itself. I see a little bit of evidence of maybe some mud and leaves maybe blocking some of the fins, but I see nothing that indicates any kind of oil leakage or refrigerant leakage. So we'll have to move ahead with the dye, the UV dye. I've put the vehicle up in the air and removed the bottom shield so we can see the AC compressor here. Here's our compressor clutch, AC drive belt, the compressor itself. And what we're looking for with the visual inspection, we're looking for a leak. So obviously any signs of oil coming out of that front compressor seal, the body, the lines on the back here, which you may not be able to see in the picture, or the lines that come in and out of the compressor. What I have here is an AC leak detection kit. It includes fluorescent dye, an ultraviolet light that we can look for the fluorescent dye with, and special glasses we can wear while using the light. It's a brand new kit, so as I open it we'll see we have the dye. We have a dye cleaner that can remove dye. Our glasses, our UV light. So let me get all these assembled, get the batteries and the light, unwrap everything, and then we'll start on it. So we have the ultraviolet light and the glasses ready. Now we can use those glasses and that light to start looking over the system to see if there's anything that our visual inspection missed. It is a little difficult to get these glasses on over my glasses, but they do fit. So I have the flashlight. I don't know if you can see that or not. I have the glasses on, so I'm ready to start looking the vehicle over. I'm probably going to have to turn the white light off in order to use this UV light, so you may not be able to see very well what's happening here, but the only way we can do it. I'm looking for a bright fluorescent yellow or fluorescent green marks, and I see a little corrosion, a little salt, but I don't see anything bright green that would indicate that we have a leak here. One thing though that's important to note is the dye is water soluble, and so if the leak occurred a long time ago, it's quite possible that all of the dye got washed away, and the only way to find this may be to add more dye and run the system. So I don't see anything so far. This is on the bottom. I'll have to drop it down and take a look the same way on the top. Again, we'll check the condenser and the lines near the condenser to see if we can see anything here. Really no evidence of leakage there either. Again, now we have the vehicle on the ground, and we're going to check. Here's our thermostatic expansion valve. That goes through to the evaporator inside. Our low side service port, no evidence of leakage around there. Here's our high side line coming, going into the expansion valve, and the high side service port. Now there may be a little evidence of leakage there. It's lighting up a little bit, although not very much. And then I can check the rest of the lines going down towards the compressor that I couldn't see from the bottom. And going to the condenser. So far I've seen no evidence either with the visual inspection or with the ultraviolet that would identify to me any kind of a major leak that could cause this system to be completely empty. Our next step now is to inject fluorescent dye into the system. So, by the way, I did send instructions on how you guys can access all data also. You could follow along, or if you're having trouble seeing what I have on the screen here, again, 2015 GMC Sierra 5.3, we are looking under air conditioning diagnosis. So what they're telling us to do is insert a 1/4 ounce charge of dye in, and the one little piece of information there, it says R134A leak detection dye requires time to work. Depending on the leak rate, a leak may not become visible for between 15 minutes and 7 days. So in order for this to work, we need to put in dye, but we also need to put in enough of a charge that the compressor will kick on and the system will run and circulate that dye around the system. I've reconnected the ACR 2000 to the vehicle. This will allow us to first recover any refrigerant remaining in the system, then apply a vacuum to it. And the idea behind the vacuum is that we'll lower the boiling point of any moisture in the system down to room temperature, allow that moisture to boil out so we make sure we're not putting moisture in the system when we recharge it. Before we begin the recovery process, I've checked the oil recovery bottle to make sure there's no oil in it. If after the recovery process we see oil in this tank, then we know that we've removed oil from the system and we're going to have to add fresh oil when we recharge. We have the service station connected to the vehicle. Step one is to recover any remaining refrigerant in the system. So here F1 is recover, we'll press that. It tells us connect the service hoses, that's been done. Open the service couplers, that's been done. We did check the oil drain bottle. We'll press start. Okay, so our system pressure is too low even for recovery. So we'll go to the main menu and we'll go to vacuum. And I'm going to select 15 minutes and press start. Up here, not sure if you can see it, it's showing us our vacuum right now, 16, 18, 19 inches of mercury. We can see the same thing on our gauges over here. We're hoping to get down as close to 30 inches as possible. So we'll give it the 15 minutes and we'll come back towards the end. So we're down below 1 minute now, and when we get to the end, one of the things we're going to really want to pay attention to, right now it says the low is at 29 inches of mercury, and if you look over here, the gauge is down all the way at the bottom. Same with the high side. High side says 28 inches, 29. So after the vacuum stops, we're going to let it sit for a few minutes and make sure that vacuum doesn't bleed up. If it can't hold that vacuum for a few minutes, then that means there's a major leak, and we really need to take a much closer look before we put any refrigerant in this system. If it's a really tiny leak, we may have to charge it with dye and let it run for a while. Okay, so we're just going to wait probably 2 or 3 minutes. Right now it's still at 29. We'll watch our manual gauge 2, see if that moves, and we'll come back in a couple minutes and check it. Before we go ahead and charge the system, I looked up the refrigerant capacity for this system. See here, our 134A refrigerant charge is 1.4 pounds. So that's what we'll set the machine for. Since we haven't lost any vacuum, this still says 29. We know we don't have a massive leak. So we're going to go ahead and put in that 1.4 pounds of refrigerant. So I'll push charge, dial in the amount, hit next, and press start. If you watch the gauges, you can see now the pressures are coming up. Reads about 50, low side reads about 50. We can also look here, it says 49, 62. We'll come back in a minute when that's done. Now we've reached our full charge of 1.4 pounds, and it's time to add the dye. The dye injector is a really simple piece of equipment. It's like a caulk gun. Here we have the dye cartridge. The dye cartridge is calibrated and it has a 1/4 ounce scale on the back. That attaches into what looks like a caulking gun. And the hose, the service hose, is going to attach to our low side port. Just screws onto the end of this cartridge. We install it in the caulking gun. Like we're painting a house. We've attached the oil injector hose to the low side service port. I'm just going to squeeze the caulking gun handle and put in 1/4 ounce And then we'll disconnect that and rehook our gauges. Now we're looking at static pressures of about 65 psi. I'm going to start the system and make sure the compressor kicks on. You'll know the compressor kicks on when it pulls the low side down and pushes the high side up. You can see here the compressor clutch did cycle on. Pressures are building. High side pressure, just about 200. Low side's averaging about 25. And the high side is kind of stabilized at about 160. So we can now go ahead and do our performance test that we were talking about right at the beginning of this. If you remember, before we did the performance test, before we attempted it, we looked up some specs and some procedures. And two things they wanted you to know before you started this were the ambient temperature, which here is 70 degrees Fahrenheit, and the humidity, which is 39. So we're getting that right off the ACR 2000. Here I've come back to the performance test page for this vehicle. And earlier what we did was we went through step 1 here and we found that our static pressure was not 50 psi. It was in fact close to 0. So that took us to leak testing, and I'm not saying we're done with the leak testing. There's still a problem. We've put the dye in, and after we run the system we'll have to figure out where that refrigerant's going. But while we do have a charge in it, we can go ahead with the performance test. So here it says record the relative humidity and the ambient air temperature at the time of the test. So we know what that is. That's 70 degrees Fahrenheit, 39% relative humidity. I'm going to go ahead and set the vehicle up. Windows and doors closed, AC on at the temperature, coldest temperature setting, everything max. And we're going to put temperature probes in the left and right center AC air outlets, start it and run it, and after 5 minutes we'll take a look at those temperatures and pressures. So the temperatures will get off those thermometers in the panel outlets, and the pressures of course will get off the gauges. And then there's a table we're going to compare those to. So I'll set things up and run the vehicle, and then we'll take a look. You can see what we're looking for here. Our temperature is somewhere in the 65 to 70 degree Fahrenheit range, and we have a very low relative humidity. So we're either on this line or on this line here. So what we're looking for is about low 30s on the low side and just over 200, maybe 235 on the high side, with a maximum discharge temperature of somewhat less than 50 degrees. So the first thing we'll look at are the pressure gauges. We'll see where they're at, and then we'll look at the discharge temperature and see where that is. Right now you can see the high side pressure is varying between about 150 and close to 200. Here it says the high side max was 196 psi. The low side is hanging steady right around 30 psi. So how does that compare to what we saw on the specification chart in the performance test? Inside the vehicle, it's a little bit noisy with the AC running on max. Here is our left center outlet, 46.1 degrees Fahrenheit. How does that compare to the spec? Also, in case it was too hard to see the digital gauge, on the other side, I put an analog thermometer, and it's showing a little bit under 50. Not sure this is as accurate as the digital one, but it's just at the top of the green. Let's talk about what we just saw in the shop. We had a 2015 GMC Sierra, and the customer's complaint was that the air conditioning did not seem to blow cold on the warm day we had recently. I can verify that concern since I am the owner of the vehicle. So it was blowing out probably at about 68 degrees. So we brought it in, and the first thing we looked at was the difference between a manual AC and heat system and an electronic automatic temperature control system. So this vehicle has an electronic automatic temperature control system. We attempted to do a performance test, so we set all of the controls where they're supposed to be for the performance test, and then when we went into the instructions for the performance test, the first thing it wanted us to do was check static pressures. So what were the static pressures? Add that to your report. That caused us to have to go into a leak check routine. So first we did the leak check, just visual, just with a regular flashlight, our eyeballs, the naked eye. When that turned up nothing, we went to looking for traces of dye with the ultraviolet light. We saw nothing there. Does that mean there's not a leak? That's a good question. What was in the system? How much? How could that have happened if there's no leak? So after we looked for a leak, we looked on the top, we looked on the bottom, we decided it was time to charge the system with some refrigerant, add dye, and now we're going to have to run the system. Do you remember how long it said it might take in order for that leak to show up? It was a wide range depending on how big the leak is. Then we attempted to do a performance test just to see, does the system work when it's full? What do you think? We compared some numbers on a chart with some numbers on thermometers and numbers on pressure gauges. Did they quite match? Is there a possible explanation for that? I can tell you that today it's only about 45 degrees outside. So I'm not so sure it's actually 70 in the shop like that ACR 2000 said. I'd be willing to bet that it's a little cooler than that. What effect does that have on refrigerant pressures, if any? You saw the chart where it asked us to first look at ambient temperature before we decided what the pressure could be. Does ambient temperature make a difference then? So put that in your report. I'll give you instructions on the report. When I post this video, there will be instructions on exactly what you have to do in order to get credit for this lab. I hope to do one of these every week. I hope to revisit that GMC and find, if there's a leak, find it and repair it. We'll see what happens. There's only so much time left in the semester, and I'm not sure what the status of parts is with what's going on in the world right now. But we'll check back into it and we'll see what happens from there. In the meantime, watch this video as many times as you have to. There's no limit on it. I'll give you the instructions for the report, and then I will give you feedback on how you did on that report, and hopefully we get you through the semester without having to take an incomplete, without having to take an F, and those of you that are ready to graduate can do so.